Welcome to the hangar. Si estás empezando en el mundo de la aviación y quieres aprender a proteger tu aeronave, no olvides darle like a este video y suscribirte para más tips de mantenimiento. A layer of wet grime trapped on your aircraft surface creates a live battery that slowly eats the metal away. This happens because the high-strength metals used to build airplanes are constantly trying to return to their natural, raw state. When we expose these refined alloys to the elements, they begin a process of decay called oxidation. This animation shows the process in action. When moisture mixes with dirt, it forms a liquid bridge that conducts electricity. This bridge completes a tiny circuit between different points on the metal, allowing a steady flow of electrons that breaks the surface down. This flow becomes much more aggressive when two different metals touch, like this steel bolt secured in an aluminum panel. If moisture connects them, the aluminum acts as the sacrificial part of the circuit. It is eaten away to provide electrons for the stronger steel. This reaction starts out smaller than the human eye can see, but if that circuit isn't broken, the decay spreads deep into the aircraft's frame, leading to total structural failure. You don't need a lab to find these hidden circuits. Most early corrosion can be spotted with 3 basic tools. You just need a bright flashlight, a small inspection mirror to see around corners, and a 5 to 10 power magnifying glass to check for surface pitting. Look at the mechanic in this photo. They aren't just looking at flat panels, they're checking tight gaps and structural seams where water naturally pools. The landing gear shown here is a major target. Because these parts are exposed to the elements during takeoff and landing, they take a direct hit from runway salt, mud, and moisture. When you know which seams and corners are most likely to trap water, your routine walk-around becomes a targeted search for specific hazards. Different metals show their damage in different ways. On aluminum, which makes up most of the aircraft, corrosion appears as a dull gray or white powdery deposit. Steel carts are easier to read. They show their age through familiar reddish-brown rust. You also have to look past the paint. Sometimes the initial decay happens underneath the finish, causing the surface to look blistered, flaky, or lumpy. Notice the texture in this close-up. This is called filiform corrosion. It creates these distinct worm-like tracks that spread beneath the tough top coat of paint, feeding on moisture trapped against the metal. If you know what to look for, the skin of the aircraft will tell you exactly where the chemical decay has started. You should also pay close attention to the fasteners. If you see a dark, soot-like ring around a rivet, it is often called a smoking rivet. This happens when two metal parts vibrate and rub against each other during flight, grinding the metal into a fine powder that bleeds out. Spotting these marks proves that corrosion isn't just about water. The physical vibrations of the aircraft can also wear the metal down into debris. The most effective way to stop these reactions is surprisingly simple: a regular washing schedule. As this diagram shows, when you wash the plane, you remove the dirt and salt that conduct electricity. Without that conductive bridge, the battery circuit is broken and the corrosion stops. Your environment determines how often you need to wash. In dry zones like the one pictured here, a full cleaning every 90 days is usually enough to keep the metal safe. However, in marine environments, where the air is thick with salt, you have to wash the aircraft every 15 days. Salt is so conductive that it speeds up the oxidation process significantly. Because the environment changes how fast corrosion grows, where you fly determines how often you need to be out here cleaning. If you find corrosion, you must protect yourself before treating it. You'll need heavy-duty rubber gloves, an acid-repellent apron, and protective safety goggles, as the cleaning chemicals are quite harsh. First, you strip the paint and clean the area thoroughly. This allows you to see the true extent of the damage hidden underneath. Then you carefully remove the corrosion and neutralize the area. You must use the correct abrasive pads. For example, using steel wool on aluminum will actually embed tiny bits of steel into the surface, creating a brand new corrosion cell. Consistent cleaning and visual checks are the best ways to avoid these difficult repairs. Catching a small patch of powder now prevents a major structural failure later. When you take care of your aircraft's skin on the ground, it takes care of you in the sky.